morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Subinda. Now we are moving on to the section which is examples. Now the subtopic is scalar multiple of a vector. So we have two questions here, but this video, due to time and due to space, we are going to only cover one example. Then in the next video, the next example. Given that P is equal to 3 of vector A minus vector B, Q is equal to 2 of vector A minus 3 of vector B, you find the numbers x and y such that xp plus yq is equal to vector A plus 9 of vector B. So what are they saying here? The numbers x and y, these are like scalars. They are scalars. That is what we are doing here. So let's write what we know this side. We have vector P is equal to 3 of vector A minus vector B, and then we have Q is equal to, or not vector P, sorry, this is just letter P. Then Q is equal to 2 of vector A minus 3 of vector B. So minus 3 of vector B, like that. Those are the two vectors we have, and then they want us to find the numbers x and y such that xp plus yq is equal to that. Let's get on and write that. So they are saying xp plus yq is equal to 9 of vector A, vector A plus 9 of vector B. So we'll say x, you multiply by p, which is 3 minus, like that. Then plus y, you multiply by 2 minus 3b is equal to vector A plus 9b, like that. So x you multiply by what letter p is. You substitute the letter with the vector. We put brackets to represent multiplication. Plus y, 2 of vector A minus 3 of vector B. Then here at this stage, we expand the brackets. We expand. We simplify by expanding. So this will be 3x of vector A minus x of vector B plus 2y of vector A minus 3y of vector B is equal to vector A plus 9b. At this stage, what we'll do is that we will group the vectors. So we're going to group the common vectors together. Right. This means we'll say the one that has vector A, we group the like terms. So 3x of vector A plus 2y of vector A minus x of vector B minus 3y of vector B, right, is equal to A plus 9 of vector B. Then here, let's factor out the vector A. It will mean 3x plus 2y, like that, of vector A. Then here we'll factor out positive vector B. So for us to factor out the positive vector B, it means we're going to leave the signs as they are. So we'll say plus, or we can factor out the negative. We can do it two parts. So this A is representing multiplication. We factor out the negative like that. Then we have vector B. We have x plus 3y of vector B is equal to vector A plus 9 of vector B. So what have we done now? We have said this quantity of vector A, this quantity of vector B is equal to that. We have just grouped like terms, we have just used algebra. Then at this point in time, everything that has vector A, we equate. Everything that has vector B, we equate. So this stage is called equate vectors. Equate vectors. This means 3x plus 2y of vector A is equal to vector A. So this is the left-hand side of the equation. This is the right-hand side. Left-hand side, right-hand side. Everything with vector A on the left, we equate to everything with vector A on the right. Then we'll have minus x plus 3y of vector B is equal to 9 of vector B, like that. Then we proceed. We'll proceed from the equating of vectors. So let's just clean up. We proceed. After here, so here we have equated the vectors. This vector is equal to that vector. The next step is a process called drop vectors. So let's just copy, you can see it right here. Let me just copy it up so that you can see what I mean. Let's write it in capital letters. We drop vectors. What we simply mean when we say drop vectors, we just forget about the vectors. Let's get what has remained. So it means we are saying 3x plus 2y is equal to 1. And then we will have our negative x plus 3y is equal to 9. So since this negative is multiplying what is in the brackets, we can do this. So 3x plus 2y is equal to 1 is our equation number 1. Then x plus 3y is equal to negative 9 is our equation number 2. So I've just divided both sides by the negative. I did that. Negative. And then it gave me negative 9 like that. So we have two equations. We're looking for the numbers x and y. Two equations. 3x plus 2y is equal to 1. X plus 3y is equal to negative 9. And then these two equations, we're now just going to solve them simultaneously. So we are solving the two equations simultaneously. So this will mean 3x plus 2y is equal to 1. Let's just write it up. So let's rewrite it. 3x plus 2y is equal to 1. X plus 3y is equal to negative 9. Draw a line. So we're going to use the elimination method. This is called the elimination method that we're going to use. So we eliminate a letter of our choice. From this equation, it is simple to eliminate the x. So we will multiply like this. The top will multiply by the coefficient in front of the x, positive 1, the coefficient in front of the x. So we are doing vice versa. Let me say like this. So while eliminating the x, here there's a 1, here there's a 3. The 3 will multiply down here. So the 3, the 1 up there. So this one will multiply the top row, and then the 3 the bottom row. Then we'll have 3x plus 2y is equal to 1. 3x, then here there is a positive 3y plus 9y is equal to negative 27. And then since both of these have a positive sign, to eliminate them we need to subtract. So which means we are going to say you can either subtract going up or going down. So I will subtract going up. 9y minus this is 2y. 9y minus 2y is positive 7y, which is equal to negative 27 minus positive 1 is negative 28. We divide by 7, y is equal to negative 4. Then we'll say let y be equal to negative 4. So in any of these equations, we say let y be equal to negative 4. So I'll choose the top one. 3x plus 2 negative 4 is equal to 1. 3x minus 8 is equal to 1. Group like terms, 3x is equal to 9. Divide both sides by 3. X is equal to 3. So therefore, x is equal to 3, y is equal to negative 4. To conclude, therefore, x is equal to 3, y is equal to negative 4. So those are the numbers or the scalars that they wanted. Thank you so much for watching. This has been Cornelius with another segment, and bye-bye.